Welcome, stargazers, to the Sleepy Astronomer. Tonight, we're going on a gentle journey through the vast, quiet reaches of space to uncover a fascinating mystery. Why is Earth the only blue planet in our solar system? While other planets dazzle in reds, yellows, or pale whites, Earth alone gleams like a sapphire in the cosmic dark. But how did this happen? What makes our world so uniquely blue? Before we begin, I'd love to know, where in the world are you watching from tonight? Whether you're lying in bed in Brazil, relaxing in a cabin in Canada, or drifting off in the stillness of Switzerland, you're most welcome here. Now, close your eyes, slow your breathing, and let's explore this peaceful puzzle together. In 1990, as the Voyager 1 spacecraft drifted nearly 4 billion miles away from Earth, it turned its camera back for one final glance at its home planet. The resulting image would become one of the most profound photographs ever taken. Earth, a tiny pale blue dot suspended in a sunbeam, almost invisible against the vast emptiness of space. That image stirred not just the minds of scientists, but the hearts of philosophers, poets, and dreamers alike. Carl Sagan, who had famously requested that NASA take the photograph, would later reflect on it with quiet reverence, calling Earth a mote of dust suspended in a sunbeam. From that unimaginable distance, our planet doesn't look like a world bustling with oceans, forests, cities, and life. It looks like a speck, a shimmer of color, barely noticeable. And yet it is blue, strikingly, unmistakably blue. That color, so soft and calming to the human eye, holds within it the secret story of how our world came to be what it is. It's not just a pretty hue, it's a fingerprint, a clue left behind by the forces of physics, chemistry, and geology that shaped our planet's past. A signature written by light, water, and air. A gentle whisper in the language of the cosmos. But let us pause for a moment to imagine what it was like to be aboard Voyager 1. There is no sound in space, only silence, vast and eternal. No up or down, no sky or ground. Just the endless blackness of the void, peppered with distant stars that have burned for millions of years. In the middle of that stillness there is Earth, glimmering blue, like a droplet of water floating in ink. From there, all borders vanish. All conflicts, all boundaries, all lines drawn in the sand, they disappear. What's left is a sphere, glowing softly, unique in its color and its meaning. That pale blue dot tells us something about the rarity of our home. In all the known solar system, no other planet looks like this. Mars is red and dusty. Venus is shrouded in thick yellow clouds. Mercury is grey and barren. Jupiter and Saturn, though magnificent, are gas giants wrapped in storms. And yet here we are on a small rocky world, enveloped in the only known atmosphere that scatters light in such a way that the planet appears blue from afar. It's easy to take for granted this blueness. We see it every day in the sky, in lakes, in oceans and rivers. But from a cosmic perspective, it is astonishing. The blueness is rare, it is delicate, it is the product of a perfect balance, a balance of distance from the sun, of gravity, of temperature, of chemical composition, and time. Had any of these ingredients been even slightly different, Earth might not have been blue at all. It might have been grey, or brown, or red. It might have been dry, or silent, or lifeless. And so, as we look at that image, the Earth barely a pixel across, it's not just its color that moves us, it's what that color represents. It represents water, the oceans that cover our world in vast rolling blankets of blue. It represents the sky, that soft blue ceiling that changes with the weather and the hour. And it represents life, the life that fills every crevice of this planet, from the deepest trenches of the sea to the tallest peaks, from the deserts to the rainforests, from you and me to the trees outside your window. This is where our story begins. Not with Earth as a world teeming with motion, but with Earth as a dot in the distance. A quiet, humble dot. And that's what makes it so beautiful. It reminds us that even the smallest, softest glimmer of light can hold entire worlds inside it. That even a single color, gently shimmering in the dark, can tell a story billions of years in the making. So tonight, as you lay your head down and listen to this tale, know that you too are part of that pale blue dot, a living thread in the cosmic fabric. And as we drift deeper into this mystery, we'll gently unravel how Earth became the only blue planet we know, and why, perhaps, that is the rarest color of all. Water. The word alone feels soothing. It flows, it shimmers, it dances with light. But water is more than just a gentle presence on Earth. It is the very heart of why our planet is blue. Over 70% of Earth's surface is covered by water. Vast oceans stretch across its curves, so wide that they seem endless from the shore. Deep beneath the surface, currents move like slow, powerful rivers, whispering through trenches and over ridges that few eyes have ever seen. Rain falls from the clouds above, feeding rivers and lakes. Ice caps gleam like white crowns at the poles. Water, in all its forms, liquid, vapor, and ice, wraps itself around our world like a soft, glistening robe. But how did it get here? Billions of years ago, when Earth was still forming from dust and rock in the early solar system, the planet was hot, violent, and dry. Volcanoes erupted constantly. The surface boiled with molten rock. In those days, the sky wasn't blue. It was thick with clouds of gas and ash, and the planet looked more like a furnace than a home. But in that chaos, something extraordinary was happening. Water was arriving. Some of it came from deep within the Earth itself, released through volcanic activity as steam. But much of it, according to one widely held theory, came from beyond. Icy asteroids and comets, traveling from the far reaches of the solar system, crashed into the young Earth. They carried with them frozen water, which slowly melted and pooled over millions of years. The skies cooled, the clouds wept, and eventually the rain began to fall and fall and fall. For thousands of years, it rained without stopping, turning the Earth's craggy surface into basins and valleys filled with water. Oceans formed, growing deeper and wider. As the planet cooled further, the violent energy of its youth gave way to a calmer rhythm. Waves lapping on shorelines, tides pulled gently by the moon. Earth had begun its transformation from a scorched rock to a water world. It is this abundance of liquid water that gives Earth its rich, deep blue hue when seen from space. Sunlight, as it hits the ocean, interacts with the molecules in a special way. Water absorbs longer wavelengths of light, like reds and oranges, and reflects shorter ones, especially blue. So when we look down from above, what we see is the reflection of that filtered light, bounced back from the surface of the seas. The deeper the ocean, the darker the blue. The clearer the water, the more vivid the color. This process is almost magical in its simplicity. There's no trick, no artificial coloring, just light meeting water and dancing back into space. But the effect is profound. Earth's oceans don't just reflect the sky, they shape how we see our planet from afar. Without them, Earth wouldn't look like a jewel. It would be dull, muted, maybe even barren. And yet, water isn't just beautiful, it is life-giving. Every living thing on this planet depends on it. From the tiniest plankton drifting near the surface of the sea to the great whales that sing through its depths, life on Earth is a water story. Even our own bodies are made mostly of water, as if the planet's essence flows within us. Imagine standing on a beach at dawn, the sky a soft pink, the waves quietly rolling in. That water has been part of this Earth for billions of years. It has seen mountains rise and fall. It has moved with the moon's pull since the beginning, and it is still here, still holding the light that makes our planet blue. Other planets may have ice, some may have vapor, but no other world we know has this. Vast, stable, liquid oceans stretching across its surface, reflecting light into the cosmos like a mirror. It is water that gives Earth its serene shimmer, its calming colour. And in that colour, we see more than just beauty. We see the memory of a violent beginning, softened by rain. So as you drift off tonight, picture that first ancient rainfall, a time when the earth began to cool, the clouds parted, and the oceans were born. Listen for the hush of waves rolling against time itself, and know that the blueness of Earth, the softness we see from the stars, began with something as simple and as sacred as water. The sky, so familiar, so comforting. It arches over us each day in a canvas of blue, fading into fiery oranges at sunset and soft violets at dusk. We look up at it without even thinking, trusting that it will always be there, quiet and endless. But that gentle dome above us holds within it one of the most important clues to why Earth appears blue from afar. It's easy to think the sky is blue simply because it reflects the oceans below. And while there is a delicate dance between sea and sky, the truth is more intricate and more wondrous. The reason our sky is blue has to do with something invisible, the atmosphere. This thin, fragile layer of gases hugs our planet, so thin it's almost like the skin on a bubble. And yet, it is powerful enough to shape how we see the world, both from within it and from the darkness beyond. To understand how the sky turns blue, we need to explore something called Rayleigh scattering, a process named after the British physicist Lord Rayleigh, who explained it in the 19th century. Sunlight, as it streams toward Earth, may look white, but it's actually made up of all colours combined, like a rainbow rolled into a single beam. Each of these colours travels in waves, but not all waves are the same. Blue and violet light have short, tightly packed waves. Red and orange light have longer, more stretched out waves. When sunlight hits the molecules in our atmosphere, oxygen, nitrogen, and trace gases, it doesn't just pass through cleanly. The light is scattered in all directions, bouncing off the particles in random paths. But because blue light waves are shorter and more energetic, they scatter much more than the other colours. This scattered blue light is what fills the sky and reaches our eyes from every direction. So when we look up during the day, we see blue, painted across the sky by invisible particles and the dance of light. From space, the atmosphere itself becomes a faint halo, a delicate shimmering ring of pale blue around the Earth. Astronauts often speak with awe about this layer. It looks so thin, so ephemeral, like a breath held in place. Yet it plays a crucial role in Earth's appearance. Not only does it create the blue sky seen from the ground, it also adds to the planet's overall bluish tint when viewed from orbit. Without this atmosphere, Earth would not only be lifeless, it would be colourless too. The oceans would still reflect some light, but without the atmosphere to scatter and soften it, the planet would lose its unique glow. Our sky changes constantly. It shifts with the weather, with the seasons, with the time of day. In the morning, the blue is pale and sleepy. At noon, it becomes a brilliant, radiant azure, and at dusk, the blues give way to deeper purples and reds as the sun sinks low, and the angle of the light stretches the waves. But all of this, the entire performance, is only possible because of the atmosphere's presence. Now imagine looking at Earth from far away through the lens of a satellite or a passing spacecraft. What do you see? Not just land and sea, but a layer of luminous mist encircling the planet. A veil of blue curved perfectly along the horizon. It softens the borders between space and surface, giving Earth a glowing outline. This soft radiance is not a trick of the eye. It is light, bent and scattered by the very air we breathe. And this layer does more than shape our view. It sustains life. It holds in warmth, filters harmful radiation, and provides the oxygen we need. In a way, Earth's atmosphere is both a guardian and an artist. It protects and it paints. Other planets have atmospheres, but none quite like ours. Venus, for instance, has a thick, choking atmosphere of carbon dioxide, cloaked in clouds of sulfuric acid. Its sky would appear yellowish-orange, hazy and oppressive. Mars has an atmosphere so thin that it barely scatters light at all. The sky there can turn pale red or butterscotch, tinted by the fine dust that drifts through it. But Earth's atmosphere is the perfect mixture, the right balance of gases, pressure and light to give us the sky we know and love. Sometimes, on a quiet afternoon, when the clouds have drifted away and the sun is high, you can lie on your back and look up into that infinite blue. It stretches out without end, soft and wide, like the surface of a still lake turned upside down. That color, the calmness of it, has soothed the minds of children and poets and dreamers for thousands of years. And though we often forget, it is a rare and miraculous thing. So tonight, as you close your eyes and breathe gently, imagine floating high above the Earth, watching the sunlight pour through that precious layer of air. Watch how the light scatters and dances, how it embraces the planet in a soft, glowing haze. And remember that without this invisible shield, there would be no sky to watch and no blue to be seen. In the quiet vastness of space, where temperatures can plummet hundreds of degrees below freezing or soar high enough to melt metal, Earth occupies a remarkably gentle place. Not too close to the burning fire of the sun, and not too far away into the frozen black, our planet orbits in a thin, almost impossibly narrow region called the Goldilocks zone, a place where conditions are just right. This balance is not accidental. It's the result of a cosmic choreography guided by gravity, time, and countless collisions over billions of years. And it is this perfect distance from the sun, an average of about 93 million miles, that allows Earth to maintain a delicate equilibrium, warm enough for liquid water to flow freely across its surface, but not so warm that it boils away into the sky. To understand the rarity of this balance, let's imagine the extremes. Take Mercury, the planet closest to the sun. With virtually no atmosphere to speak of, its surface is scorched by solar radiation. Temperatures during the day can climb above 800 degrees Fahrenheit, hot enough to melt lead, while nights plunge into freezing cold, since there's nothing to trap the heat. It's a world of harsh contrasts, where life as we know it could never find a home. Next comes Venus, our neighbor in the other direction. Venus is nearly Earth's twin in size, but its proximity to the sun has led to a very different fate. Its thick atmosphere, made mostly of carbon dioxide, traps heat so efficiently that the planet's surface reaches a blistering 900 degrees Fahrenheit. It's the hottest planet in the solar system, not Mercury. The air pressure on Venus is so intense, it would crush a human within seconds. Its clouds are made of sulfuric acid, and the sky there is a permanent, oppressive yellow. No oceans, no blue, no life, just endless toxic heat. Now let's look the other way, to Mars. Mars is smaller than Earth and farther from the sun. While it once may have had rivers and lakes, its thin atmosphere couldn't hold in the heat. Over time, most of the water evaporated into space, and the planet became dry and cold. Temperatures often drop below -100 degrees Fahrenheit. Any water left today is locked away as ice beneath the surface or in the frozen polar caps. Mars is rust red and silent, its skies tinted in a dusty, pale orange. It has beauty, but not warmth, potential, but not the conditions to support oceans or blue skies. Earth, then, is the exception. In this solar system of extremes, our planet exists within the narrow window that allows water to remain in its liquid state. This is no small detail. Water, as you may remember, is the foundation of our blueness, and more than that, the foundation of all life. But liquid water can only exist within a very precise range of temperatures. Too hot, and it turns to vapor. Too cold, and it becomes ice. Earth's temperature range sits comfortably in between. The result? Rivers flow, rain falls, oceans glisten under the sun. But temperature alone isn't the whole story. Earth's atmosphere also plays a crucial role in maintaining this balance. The greenhouse effect, a term often misunderstood, is actually a natural and necessary process. Gases like carbon dioxide, water vapor, and methane trap some of the heat from the sun, keeping the planet from freezing over. Without this gentle insulation, Earth would be a frozen wasteland. It's only when this balance is tipped too far, when greenhouse gases accumulate beyond natural levels, that warming becomes dangerous. Another key element is the Earth's rotation and axial tilt. Our planet spins steadily, giving us days and nights. It also tilts slightly on its axis, about 23.5 degrees, which gives rise to the seasons. This variation helps distribute sunlight across the planet more evenly throughout the year. It keeps one hemisphere from burning while the other freezes, and allows ecosystems to adapt to predictable cycles of warmth and cold. Then there's the Moon. Our large natural satellite stabilizes Earth's tilt, preventing wild shifts in climate. Without the Moon, Earth's tilt could swing chaotically, leading to climate swings that would threaten the stability of water, ecosystems, and life itself. The Moon also creates tides, regular movements of water that stir the oceans and help regulate planetary temperature. And let's not forget Earth's magnetic field, generated by its molten core. This invisible shield deflects charged particles from the sun, known as the solar wind, that could otherwise strip away our atmosphere and leave us barren like Mars. Thanks to this protection, Earth has retained the gases necessary to hold warmth and moisture, and in turn, to remain blue. It's almost poetic, really. The blueness of Earth, the tranquil, calming hue we see from the stars, is the outward expression of 1,000 inner balances. Distance from the sun, composition of the atmosphere, rotation, tilt, the presence of the Moon, even the invisible magnetism deep within the Earth's belly. Every part of it had to fall into place. If any one factor had been just slightly different, Earth might have been another Venus, sweltering and smothered in cloud, or another Mars, dry and faded, whispering of what could have been. Instead, we live on a planet where the sky is blue, and the oceans move with the tides, where rain falls and rivers run, where warmth meets coolness in perfect measure. So tonight, as you rest your head and breathe in the stillness, imagine the Earth from above, a small blue orb spinning quietly in a sea of darkness, balanced, peaceful, cradled in just the right place to be everything it is, everything we are. The miracle of warmth, not too much, not too little, made visible in the color blue. High above the Earth's surface, beyond the trees and the rooftops, beyond the thin, breathable air we take in with every gentle breath, there floats something quiet and magnificent. Clouds. They drift slowly across the sky, sometimes white and puffy, sometimes grey and dense, sometimes painted in gold or tinged with violet at sunset. But when we step back, far back, and look at Earth from space, these clouds take on a different kind of beauty altogether. They become elegant swirls of white, curling over blue oceans and green continents like soft brushstrokes on a living canvas. From orbit, these clouds are not just weather, they're contrast. They are what makes Earth shimmer, what gives it texture, what transforms it from a simple sphere of blue into something more dynamic, more alive. Their pure whiteness, in combination with the deep blue of the oceans, gives our planet its marbled appearance. The clouds are not permanent fixtures. They move, they evolve, they vanish and reform in endless patterns, each one fleeting and unique. And yet, together, they are part of what makes Earth appear so distinct in the darkness of space. Clouds form from water vapor, invisible to the eye until it condenses around tiny particles in the air, like dust, salt, or even microscopic pollen. When enough of this vapor gathers and cools, it becomes visible, turning into the soft, pillowy structures we know. Some hover low to the ground, like fog. Others climb miles into the sky, towering and majestic. But from space, these differences vanish. The clouds become flattened outlines of weather systems, spirals of motion that tell quiet stories about the planet below. The stark white of clouds reflects sunlight. This is what makes them so bright when viewed from orbit. They scatter and reflect incoming solar radiation, bouncing much of it back into space. This reflectivity, called albedo, is important for Earth's energy balance. Clouds help regulate the planet's temperature, acting as both shields and blankets, cooling the surface during the day by reflecting sunlight and trapping warmth during the night by holding in heat. Their effect is subtle and complex, but without them, Earth would not be the same. Its climate would shift, its blueness would dull. Imagine the Earth without clouds, just the vast blue of the ocean, stretching without interruption. Beautiful perhaps, but uniform, monotone. What makes Earth so visually arresting when seen from afar is the interaction between water and sky, between blue and white. This mixture of color and contrast creates a dynamic presence. Earth doesn't just sit in space, it glows, it moves, it lives. The clouds swirl with storms, dance with jet streams, and stretch across continents like breath made visible. Consider a hurricane. Seen from the ground, it is terrifying, a churning mass of wind and rain. But from above, it becomes something else, a vast, spiraling sculpture of nature. The eye at the center is still. The arms stretch outward in symmetry and power. It is a reminder of how beautiful and how powerful Earth's weather systems can be. Even gentle clouds, those that float above your home on a quiet afternoon, are part of a planet-wide system that shifts and breathes with the seasons. Clouds also reveal the story of Earth's atmosphere. They show us where air is rising, where moisture is gathering, and where heat is being exchanged. They can stretch in long, linear patterns over the ocean, tracing the invisible winds that flow around the globe. They form in the shadow of mountains, curl over islands, and gather in the tropics where heat and water rise into the sky. From above, they look like lace, delicate, transient, ever-changing. There's another side to this story too, a poetic one. Throughout human history, we've looked to the clouds not just as weather, but as symbols. They've been the home of the gods, the source of dreams, the messengers of change. We've watched them from the fields, from ships at sea, from windows on rainy days. We've imagined shapes in them, found comfort in their movement, and felt something deeply human as we gazed upward into their shifting forms. All of this, the science, the symbolism, the beauty, converges when we see Earth from above. When we look down at our planet and see not just blue oceans and brown land, but streaks and swirls of white moving softly through the sky. It's a living watercolor, painted new each day by the wind and the warmth, the sun and the sea. Clouds, in their quiet presence, do more than mark the weather. They complete the picture of Earth's beauty. They offer brightness to its darkness, structure to its softness. Without them, our planet would still be blue, but not alive, not dynamic, not complete. So as you drift into rest, imagine lying on a field, watching clouds drift slowly across a deep blue sky. Then imagine rising higher and higher until the ground falls away and you're floating in space, looking back at your home. There it is, a shimmering sphere, wrapped in clouds, spinning slowly beneath the stars. A world where light and water, sky and mist all come together to paint the only planet in the solar system that wears blue like a robe. And in those drifting clouds, still moving gently even as you sleep, is the quiet pulse of Earth itself, endlessly renewing, endlessly beautiful. Beneath the soft blue sky and above the vast blue ocean lies a fragile, invisible force that quietly shapes nearly everything we know and love about our planet. It doesn't sparkle or shimmer. You can't hold it in your hands or see it directly. And yet without it, the Earth would be silent, lifeless, and colorless. This force is our atmosphere, a shimmering shield of gases that wraps around the planet like a protective veil. And though it may seem delicate, this shield is the very reason our planet remains blue, warm, and alive. The atmosphere stretches from the surface of the Earth to about 10,000 kilometers above, gradually thinning as it rises until it fades into the blackness of space. It is made mostly of nitrogen and oxygen, along with small amounts of other gases like argon, carbon dioxide, neon, helium, and a trace of ozone. While this mixture may seem ordinary, it is precisely this delicate blend that has allowed life to flourish, oceans to remain liquid, and the sky to glow with that unmistakable shade of blue. At first glance, the atmosphere might seem passive, like a quiet background presence. But in truth, it is constantly in motion, pulsing with winds, carrying clouds, trapping warmth, and scattering sunlight. Every day it performs countless miracles in silence. One of its most important roles is protection. High above us, in the stratosphere, lies a thin layer of ozone. This invisible barrier absorbs most of the sun's harmful ultraviolet radiation, which would otherwise scorch the surface and damage all forms of life. Without the ozone layer, the very DNA of living organisms would be under constant attack. The Earth's blueness would be the least of our concerns, but the ozone is there, working tirelessly, filtering light, allowing just enough of the sun's energy to reach us, enough to warm but not to burn. And it's not just light that the atmosphere defends us from. Every day, tiny meteoroids, some no larger than a grain of sand, others the size of pebbles, race toward Earth at incredible speeds. When they strike the atmosphere, the friction of entry causes them to burn up before they ever reach the ground. We see them as shooting stars, brief streaks of light in the night sky. But without the atmosphere, these harmless sparks could become dangerous missiles. In this way, the atmosphere acts like an unseen guardian, taking the blows of space so that we don't have to. But perhaps the most beautiful interaction between our atmosphere and the cosmos is the way it plays with light. As sunlight enters our atmosphere, it bends, scatters, and splits, like music flowing through an intricate instrument. The shorter blue wavelengths of light bounce off air molecules more easily than the longer red ones. This scattering is what fills the sky with blue during the day. At sunrise and sunset, the light has to pass through more of the atmosphere, so the blue is scattered away and we see brilliant oranges, pinks, and purples instead. It's a performance that has been playing every day for billions of years, and we are the lucky audience. This scattering of light doesn't just make our skies blue, it also contributes to Earth's bluish glow when viewed from space. The atmosphere refracts and reflects sunlight in such a way that it adds a faint blue halo around the planet, a soft ring that makes Earth look like a glowing sapphire floating in the black sea of the universe. From the International Space Station, astronauts have described this as one of the most moving sights. The thin, fragile line of blue that separates us from the vacuum of space. The atmosphere also plays a crucial role in keeping Earth's temperature stable. During the day, it allows sunlight to warm the surface. At night, it traps some of that warmth, preventing it from escaping too quickly. This natural insulation system, known as the greenhouse effect, keeps the Earth's climate within a range that supports life. Too much greenhouse gas, and the planet overheats, as we see on Venus. Too little, and the planet freezes, like on Mars. Earth, again, finds the perfect middle. And in that balance, life thrives. Even the air we breathe is a gift of this shield. The oxygen we depend on was not always present. It was produced over billions of years by tiny organisms, cyanobacteria and algae, that released it through photosynthesis. The atmosphere changed because life changed it, and in return, that atmosphere allowed life to grow more complex, more diverse, and more resilient. Think for a moment about how thin this protective layer truly is. If Earth were the size of an apple, the atmosphere would be no thicker than its skin. And yet within this skin lies everything we know. Weather, wind, rain, breath, flight, sound, and the sky itself. Everything that moves or breathes or grows in the open depends on this narrow envelope of gases. Other planets have atmospheres, but they are not like ours. Mars has one, but it's thin and weak, unable to trap heat or hold much moisture. Venus has one, but it's thick and toxic, crushingly dense and cloaked in sulfuric clouds. Earth's atmosphere is rare, it is balanced, it is gentle, it is just right. And this just right quality is what allows blue to exist here in a way it cannot anywhere else. The atmosphere is the stage on which sunlight performs, water moves, and life unfolds. It's not just something we live under, it's something we live within. Every breath you take, every breeze that brushes your skin, every ray of sunlight that warms your face is shaped by this invisible shield. So tonight, as you close your eyes and listen to your own breathing, remember that you are part of that breath. You are part of the atmosphere. You are held in place by this gossamer veil, warmed by it, protected by it, and painted into a world of blue because of it. Let that thought drift with you, gentle as air, until sleep carries you softly into the sky. Long ago, Mars may not have been the silent, dusty world we know today. It may have once shimmered with water, rivers flowing through valleys, lakes pooling in lowlands, perhaps even a great ocean in its northern hemisphere. It may have had rain, clouds, maybe even a faint blue sky. But all of that is gone now, and what remains is a haunting portrait of a world that almost was. Today, Mars is red. Not just any red, but a deep, iron-tinged hue that stretches across its deserts, canyons, and dunes. The planet's surface is coated in fine dust, rich in iron oxide, rust. And that rust gives Mars its color, a reminder of what's left when water vanishes and time is allowed to pass in silence. But why didn't Mars stay blue? Why did Earth keep its oceans, its clouds, and its breathable sky, while Mars faded into stillness? To begin to understand this, we must look deep into the heart of the planet, not at its surface, but at its core. Earth has a powerful magnetic field, generated by molten iron churning within its core. This magnetic field forms an invisible bubble around the planet called the magnetosphere, which deflects harmful solar radiation and charged particles from the sun. It acts as a shield, protecting the atmosphere from being stripped away by solar winds. Mars, however, does not have such a shield. At some point in its early history, the core of Mars cooled and solidified, and with it, the magnetic field collapsed. Without this protection, solar radiation began to batter the Martian atmosphere, slowly peeling it away, molecule by molecule, over millions of years. The air grew thinner and thinner until it could no longer support liquid water on the surface. The sky dimmed. The pressure dropped. Water, once stable, either evaporated into space or became locked away as ice beneath the soil. The planet lost its breath, and with it, its blueness. This thinning of the atmosphere also meant a dramatic change in temperature. Without enough air to trap warmth from the sun, the surface of Mars grew cold. So cold, in fact, that even on a sunny day, the temperature might barely rise above freezing. And at night, it plummets to levels that would freeze human skin in seconds. In such a world, even if water did exist, it wouldn't stay liquid for long. But evidence of Mars's watery past is everywhere. Dry riverbeds wind through ancient terrain, deltas fan out like fingerprints in the dust, and minerals that only form in water are scattered across its surface. Orbiters have captured images of what appear to be shorelines, flood channels, and even frozen lakes. Rovers have rolled across rock formations that were shaped by water's slow erosion. All of these clues whisper of a time when Mars may have been warm enough, wet enough, and blue enough to resemble a very early Earth. And yet something was missing. Mars is only about half the size of Earth, and its gravity is much weaker. This made it harder for the planet to hold onto its atmosphere in the first place. As gases floated upward, they escaped into space more easily than they would have on a larger, more massive planet. So even before its magnetic field vanished, Mars was already vulnerable to atmospheric loss. And once the magnetic shield was gone, there was little to stop the slow, invisible erosion of its potential. Today, Mars has an atmosphere, but it's a ghost of what it once was. It's thin, less than 1% the density of Earth's, and made mostly of carbon dioxide. It's far too cold and dry to support liquid water for long, and far too thin to scatter sunlight in the way our atmosphere does. Instead of a bright blue dome, the Martian sky is often a dull butterscotch color, tinted by the red dust that floats endlessly through the air. During dust storms, the entire planet can be blanketed in a coppery haze, blotting out sunlight for days or even weeks at a time. And yet, the loss of blueness on Mars is not just a matter of science. It's a kind of quiet heartbreak. Because in Mars, we see a reflection of what could have happened to Earth. A world that had water and lost it. A planet that might have sparkled with rivers and clouds, but now lies silent and still. It serves as both a warning and a wonder. A place where life may have tried to begin, only to be stopped by the cold breath of time. Some scientists still dream that microbial life may exist beneath the surface, hidden in salty underground lakes or deep within the planet's crust. If it does, it would be a tiny ember in a long cooled fire, a flicker of what once was. But for now, Mars remains dry, red, and quiet. And Earth remains blue. What saved us was a perfect storm of protection, a magnetic field that held back the solar winds, an atmosphere thick enough to trap warmth and support oceans, and just enough gravity to hold on to the breath of life. All the things Mars lacked, Earth had. All the conditions Mars lost, Earth preserved. So as you rest tonight, drifting into sleep, imagine the lonely beauty of Mars. A planet where rivers once ran and skies might have once gleamed. A place that tried to be blue, but couldn't hold on. And then, bring your mind back to Earth, to the oceans, the sky, the clouds, the wind, to the shimmering shield that still wraps around us. Blue is not just a color, it is survival, it is protection. It is the memory of water, the presence of atmosphere, the gift of gravity, and the delicate balance of a world that, against all odds, stayed alive. Far beyond the orbit of Earth, past the scorched landscapes of Mercury, the volcanic clouds of Venus, and the dusty plains of Mars, lies a world cloaked in deep blue. It shimmers like a gemstone in the cold, outer reaches of our solar system, glowing with an eerie, captivating light. This is Neptune, the 8th planet from the Sun and one of the most mysterious and distant places we've ever glimpsed. When spacecraft and telescopes first sent back images of Neptune, many were struck by how blue it looked. In fact, to the untrained eye, Neptune might seem like Earth's twin from afar. Both blue, both round, both suspended in the dark silence of space. But that similarity is an illusion, because Neptune's blue is not the same as Earth's. It's a different kind of blue, darker, colder, more alien. And it comes not from water, clouds, or oceans, but from something far more unusual: chemistry. Unlike Earth, Neptune is not a rocky planet. It's a gas giant, a swirling, massive ball of gases with no solid surface, made mostly of hydrogen and helium. But unlike Jupiter and Saturn, which appear golden, orange, or greyish-brown, Neptune is vibrant blue. Why? The answer lies in a gas that is both simple and surprising: methane. In Neptune's upper atmosphere, trace amounts of methane absorb certain wavelengths of sunlight, specifically red and infrared light. As the red light is absorbed, the blue and green wavelengths are scattered and reflected back into space. The result is the planet's striking blue appearance. Methane, though present in only small amounts, has an outsized effect on the color we see from millions of miles away. But this blue is not the blue of life. It's not the blue of water, or sky, or sea spray on a windy day. Neptune's blue is lifeless, cold. It reflects no oceans, harbors no clouds of liquid rain, no rivers that flow, no mist that rises over warm ground. It is a beautiful surface effect, a product of physics and light, of frozen gases and solar rays. It's a reminder that blue, like so many things in the cosmos, can have more than one meaning. The temperatures on Neptune are unimaginably low. At its cloud tops, the average temperature is around -370 degrees Fahrenheit, colder than any place on Earth has ever been. The winds that whip through its atmosphere are the fastest in the solar system, reaching speeds of over 1,200 miles per hour. Massive storm systems swirl across its face. One of them, the Great Dark Spot, was similar in size to Earth itself when it was first observed by Voyager 2 in 1989. These storms are powerful, but not driven by sunlight. Neptune receives only a fraction of the solar energy that Earth does. Instead, its violent weather may be fueled by internal heat left over from its formation. Unlike Earth, which is illuminated by a sun-drenched sky and warmed by surface radiation, Neptune exists in dim twilight. Even at high noon on Neptune, the sun appears as only a bright star in the distance. The planet glows, but it glows without warmth. Its beauty is distant, mathematical, like a fractal made of ice and light. It's not the kind of place where you'd expect to find blue lakes or waves lapping at a beach. There are no beaches. There is no land. In the core of Neptune lies a dense mix of rock and ice, surrounded by a thick mantle of water, ammonia and methane, frozen or compressed into exotic forms that we can barely imagine. Some scientists believe that, under the crushing pressure inside Neptune, methane could break apart, releasing carbon atoms that might crystallize into diamonds. These diamonds, heavier than the surrounding fluids, would rain down through the icy layers in shimmering cascades, diamond rain in the deep heart of a frozen blue giant. It sounds like a dream or a fairy tale, but it may be one of the strangest truths in our solar system. Even stranger is the thought that Neptune's deep blue may conceal more than just mystery. It may echo with forgotten histories. Though Neptune is unlikely to support life as we know it, it raises questions about how color alone can be misleading. We are drawn to blue, perhaps because it soothes us, reminds us of water, of air, of home. But Neptune's blue, while dazzling, is deceptive. It is the blue of gases, of absorption and reflection, not the blue of lakes and sky. This distinction matters because when we look at Earth and see it's blue, we are not seeing a surface trick. We are seeing something essential. We are seeing water in motion, clouds in transformation, sky shaped by sunlight and air. We are seeing the touch of life and the breath of atmosphere. We are seeing interaction, and more than that, we are seeing something fragile. On Neptune, blue endures no matter what. It's the color of methane, stable and constant in the cold, thin upper air. But Earth's blue, so delicate, so dependent on balance, could be lost if that balance ever shifts. It is a color earned through harmony, a color that reflects the precise distance from the sun, the protective layers of atmosphere, and the presence of a liquid that flows through rivers, oceans, and even through us. Neptune, in a sense, is a kind of mirror. It shows us that beauty does not always mean life. That color does not always mean comfort. It reminds us that while blue can exist in many forms, only one version of it, our version, tells the story of a living planet. So as you fall into sleep tonight, imagine drifting far beyond the Moon and Mars, beyond the asteroid belt and the rings of Saturn, until you reach that distant place where Neptune spins slowly in the darkness. Imagine looking down on its glowing blue surface, the color of twilight frozen in time. Then turn your gaze homeward and see once more the Earth, blue not from methane, but from water, from sky, from cloud and light and life. 2 planets, both blue, but only one alive. From the moment Earth first cooled, from the time the oceans formed and the skies began to scatter sunlight, the stage was set. But it was only with the arrival of life that the script of our planet truly began. Life didn't just evolve on Earth, it transformed it. Slowly, silently, persistently, life changed the air, the land, the water, and even the color of the planet itself. It took billions of years, and most of it happened long before humans walked the Earth. But without the presence of life, especially the smallest, simplest forms, Earth may never have become the vivid blue world we see today. It all started with microscopic organisms. Over 3 billion years ago, tiny single-celled life forms began to appear in Earth's oceans. These ancient organisms didn't breathe oxygen. In fact, the early Earth had almost none. The air was mostly carbon dioxide, methane, and other gases that would be toxic to humans today. But among these primitive microbes were a special kind, cyanobacteria. These remarkable beings had developed a way to harness sunlight and convert it into energy through a process we now call photosynthesis. In doing so, they released a byproduct, something that had never been abundant in the Earth's atmosphere before: oxygen. At first, the oxygen they released reacted with iron in the oceans, turning it into rust and settling it onto the sea floor. This process continued for millions of years until the ocean could absorb no more. Only then did oxygen begin to collect in the atmosphere, slowly transforming it over countless generations. This event, called the Great Oxygenation Event, was one of the most profound turning points in Earth's history. It turned a planet with a murky alien sky into one with the foundation for breathable air. The sky began to shift toward the soft blue we know today, and the air began to favor life that would depend on oxygen, including us. But cyanobacteria didn't just shape the atmosphere. They played a direct role in maintaining the conditions that allow Earth to stay blue. By regulating carbon dioxide levels through photosynthesis, they helped keep Earth's temperature in a range that allows liquid water to exist. They formed the base of early ecosystems. They gave rise to more complex organisms, and eventually, they became the ancestors of the chloroplasts found in modern plants. The green engines that drive photosynthesis in every leaf and blade of grass. Plants, algae, plankton, all of them descended in some way from these early oxygen makers, continued this work on a grander scale. forests and grasslands on land, plankton blooms in the oceans, all of them breathe in carbon dioxide and breathe out oxygen. All of them shape the air, regulate the temperature, and keep the great water cycle moving. The oceans in particular owe much of their health and their colour to life. The top layer of the sea, the photic zone, teems with microscopic organisms called phytoplankton. These tiny plant-like creatures drift with the currents, feeding on sunlight and nutrients. They are the lungs of the ocean, responsible for producing a staggering amount of the world's oxygen, more than all the forests and jungles combined. But they do more than just provide air. They also influence the colour of the water itself. Clear, nutrient-poor waters appear a deep, pure blue, while areas with dense populations of plankton can appear greener or even turquoise from above. The specific shades of blue that Earth reflects into space depend in part on where life is thriving beneath the surface. In this way, the very tone of Earth's blueness is a dynamic signature of life, changing with the seasons, with ocean currents, with plankton blooms that can be seen from space. And life doesn't just shape the oceans. It influences the clouds, the climate, and even the soil. Trees release moisture into the air through a process called transpiration, feeding the formation of clouds. Microbes in the soil cycle nutrients, regulate gas exchange, and interact with plant roots in ways that keep ecosystems functioning. Coral reefs, built by living polyps, create entire underwater landscapes that alter local ocean chemistry and colour. Even the polar ice caps are influenced by the tiny organisms that live in and beneath them. Life creates feedback loops. It stabilizes what would otherwise be fragile. If the Earth were purely geological, with no living things to moderate its systems, the planet might have swung wildly between extremes: too hot, too cold, too dry, too toxic. But life has always worked, sometimes invisibly, to smooth out the chaos. It has adjusted the atmosphere, balanced the greenhouse gases, circulated the nutrients, and absorbed the shocks of climate and time. It is life that has made Earth not just habitable, but stable. And humans, too, are part of this story. Though our influence is recent, we have become one of the dominant forces shaping the Earth. Our cities reflect sunlight, our industries release gases, our farming changes the chemistry of rivers and seas. We plant trees, we clear forests, we add to the atmosphere and remove from it. And now, more than ever, we are aware that our choices ripple across the entire system that gives Earth its colour, its balance, its life. The blue of Earth is not a static thing, it is a living process. It is renewed every day by sunlight falling on leaves, by clouds forming above rainforests, by waves stirred by wind that was born in a sun-warmed desert. It is adjusted by animals breathing, plants growing, bacteria dividing, and oceans circulating. This is what makes Earth's blue so different from the blue of Neptune or the brief water trails on ancient Mars. Earth's blue is animated. It is alive in the deepest sense. Every patch of cloud, every shimmer of water, every breath of wind is part of a planetary network, shaped and sustained by life. So as you lay down tonight and close your eyes, picture this. You are not just lying on the surface of a rock in space. You are resting within a living system. The air you breathe was once inside a tree. The water you drink has been part of a cloud. And the blue that surrounds your world, the blue that calms and soothes and inspires, is there because life made it so. And because life, including yours, is still making it so. From a distance, Earth appears almost too perfect. Its swirling clouds, endless oceans, and gentle glow create a picture of serenity that no other planet in our solar system can match. It hangs there in the darkness like a fragile ornament, glowing with soft blues and radiant whites, quietly spinning in the void. But this beauty, as breathtaking as it is, hides a deeper truth. Earth's blueness, its oceans, its atmosphere, its reflective clouds, is not a given. It is not permanent. It is, in fact, fragile. When we call Earth the only blue planet, we are not simply describing its color. We are recognizing an intricate balance, a delicate harmony of forces that took billions of years to settle into just the right configuration. It is a balance that can be disrupted, and, increasingly, we are beginning to see how easily that can happen. Earth's blueness depends on water, it depends on air, it depends on temperature and light and life itself. All of these are connected and each depends on the other. Take away one or disturb it too much, and the color begins to fade. Not all at once, not in a single moment, but gradually, subtly, like the dimming of a lantern whose flame is weakening. Human activity over the past 2 centuries has begun to push this balance. We have altered the atmosphere by releasing greenhouse gases in vast quantities. Carbon dioxide from burning fossil fuels, methane from agriculture and landfills, and other industrial pollutants that thicken the atmospheric blanket. At first, the effects were small, almost imperceptible. But now they are becoming visible. The planet is warming, ice caps are melting, sea levels are rising, weather patterns are growing more extreme. Forests that once helped balance carbon are being cut down or burned. Oceans, once stable and self-regulating, are absorbing more heat and carbon than ever before, leading to acidification, coral bleaching, and the collapse of delicate marine ecosystems. Even the color of the ocean is changing in places, as plankton populations shift or disappear entirely due to temperature and nutrient changes. Our atmosphere, the very thing that gives Earth its blue halo, is also at risk. As pollutants rise, the protective layers of ozone and natural greenhouse gases are altered. While we have made progress in addressing some threats, like the depletion of the ozone layer, others continue to grow. The more carbon we add, the more the atmosphere traps heat. The more heat it traps, the more water evaporates, storms intensify, and climate systems are pushed beyond their limits. We may not notice these changes all at once. The sky is still blue, the oceans still shimmer, but the underlying systems that maintain these colors are straining. Earth's blueness, its beauty, its calm presence from afar, is no longer as secure as it once was. And yet, this is not a story of doom. It is a story of awareness, a reminder. Because if Earth's beauty is fragile, that also means it is precious, and precious things can be protected if we choose to do so. Already, around the world, people are working to restore the balance. Reforestation projects are planting new trees in places long deforested. Innovations in renewable energy are reducing the need to burn carbon-based fuels. Scientists are monitoring the health of the oceans, studying coral reefs, mapping ice sheets, and modeling the climate with ever greater precision. Activists are speaking out. Youth are marching. Communities are coming together to protect the Earth, not just for themselves, but for generations still to come. And that, perhaps, is the most hopeful part of Earth's blueness. It connects us. Across nations, across languages, across cultures, everyone lives under the same sky. Everyone depends on the same water. Everyone is part of the same atmosphere. The beauty we see from space is not just visual, it is symbolic. It reminds us that we are all passengers on this tiny, fragile world. That no matter where we are, we all share the same home. Imagine Earth now, from the viewpoint of an astronaut aboard the International Space Station. They look down at the planet, watching it turn slowly, the clouds moving in elegant spirals, the continents glowing in the morning sun. No borders are visible, no politics, no divisions. Just Earth, blue, alive, and alone in the endless black. They know, as we must, that this beauty is not to be taken for granted, that this fragile jewel, with its thin skin of air, and its shimmering coat of water is a miracle. One of a kind, the only world, out of all the ones we've studied, that reflects light in the specific way that makes it blue and keeps it alive. So as you close your eyes tonight, as your breathing slows and your thoughts drift away, picture the Earth not as something beneath your feet, but as something whole, floating, turning, breathing, alive because of water, because of air, because of life, and because of you. You are part of that balance, part of that story, part of what makes the planet beautiful. The blueness of Earth is a treasure and a responsibility, one we can carry gently, one we can protect, so that long after we are gone, the planet may continue to glow in the darkness, blue and full of life for all those who come next.